All right, let's dive right in. Today we're talking about one of the oldest mysteries in all of mathematics, prime numbers. For centuries, they've just seemed random, like cosmic static with no rhyme or reason. But what if I told you that randomness is just an illusion? What if, hidden deep inside the primes, there's a secret music, a harmonic structure we're only just now learning how to hear?
This one idea is really the heart of everything we're going to talk about. It suggests that for thousands of years, mathematicians might have been looking at primes completely the wrong way. And this isn't just some abstract thought experiment. No, this is a discovery that could literally change everything, from the purest forms of math to the very foundations of our digital security.
So this is the big shift in thinking. On the left, you've got the classic view. Primes are just chaotic, totally unpredictable islands of numbers. But on the right, that's the new, radical idea, that primes are actually expressions of an underlying harmonic field. So instead of random noise, think of a complex, beautiful symphony. We're basically shifting our whole perspective from chaos to a kind of cosmic harmony.
So how in the world do we find this hidden music? Well, it turns out the secret wasn't in the prime numbers themselves. Nope, it was in the empty spaces between them.
It's such a simple idea, but it's profound. Instead of just looking at the primes, 2, 3, 5, 7, 11, researchers started looking at the jumps between them. The gap between 3 and 5 is 2. The gap between 7 and 11 is 4. And this sequence of gaps, which everyone used to think was just meaningless noise, turned out to be the key to the whole thing.
Okay, so what happens when you take those gaps and treat them like a signal? You uncover something absolutely extraordinary, a rich, structured landscape that scientists are now calling the prime scalar field.
And the process itself sounds complicated, but it's actually pretty straightforward. You take the prime gaps, you treat that whole sequence like it's a sound wave, and then you run it through something called a Fourier analysis. It's the same math that audio engineers use to separate out different frequencies in music. And when you do that, bam! Clear, distinct harmonic peaks just emerge from the noise. It's like tuning an old radio, past all the static and landing on a perfect, clear station.
And the result is incredibly specific. This isn't just some vague, fuzzy pattern. There's a consistent, rhythmic pulse that repeats all the way through the prime numbers, a specific rotational frequency, like finding the exact tempo of a cosmic beat. For you math folks, that's a phase period of about 2.34 radians. It's like the universe has a natural rhythm, and it was hiding in primes all along.
And if that wasn't mind-blowing enough, it gets even stranger. This whole harmonic structure, it's fractal. The exact same patterns and nodes you see in the first few thousand primes, they show up again millions, even hundreds of millions of primes later. They call this scalar recurrence. It reveals this deep, self-similar order, kind of like a musical theme that repeats in different octaves all throughout an epic symphony.
Okay, this is all fascinating math for sure, but why does it matter in the real world? Well, because this ancient pattern might just be the solution to a very modern and a very urgent problem.
You see, right now, almost everything we do online, your banking, your messages, your shopping, it's all protected by encryption that relies on certain math problems with prime numbers being really, really hard to solve. But the looming threat of quantum computers completely changes the game. There are algorithms, like the famous Shor's algorithm, that are designed to solve those exact problems with terrifying speed.
And this table really shows you just how serious this is. RSA, elliptic curve, Diffie-Hellman, these are the pillars of our digital security, and they are all completely vulnerable. Once powerful quantum computers are a reality, this stuff won't just be cracked, it'll be shattered. We desperately need a new kind of lock, one that quantum computers just can't pick.
And this is where the prime scalar field comes roaring back into the picture. What if we could build a totally new kind of cryptography? Not based on individual prime numbers, but on the complex harmonic landscape that they create.
The whole idea is based on a new kind of hardness. See, old encryption was based on problems that are hard to calculate, like factoring a massive number. This new idea is based on a problem that's hard to navigate. Imagine trying to find one specific unique grain of sand in a vast, shifting, high-dimensional desert. It's a problem of geography, not algebra. And that structural, non-algebraic nature is exactly what makes it resistant to those formula-based quantum attacks like Shor's algorithm.
So how does it actually work? Well, in a nutshell, the secret keys are basically derived from that unique musical signature of the prime field. Encrypting your data is like hiding it somewhere in that incredibly complex harmonic landscape. Trying to find it without the key, without the map, is practically impossible,
even for a super powerful quantum computer. This all sounds fantastic in theory, right? But is it actually practical? Can it really work in the real world? Let's take a look at the numbers.
Okay, let's talk performance. Now, looking at this chart, you can see that this prime scalar field cryptography isn't as blazing fast as our current classical standards like AES. But, and this is the important part, it's right there in the ballpark with the other leading post-quantum candidates like Kyber. At 145 megabytes per second, it's absolutely fast enough for the vast majority of things we do every day.
And what about strength? Well, it delivers 256 bits of equivalent security. To put that in simple terms, that means it's as tough to crack as the highest encryption standards we use today to protect, top secret government data. So this isn't just some neat idea, it's a genuinely robust security solution.
So, the bottom line is this. We're facing a futuristic threat from quantum computing. And the answer might have been waiting for us all along, hidden inside the most fundamental objects in all of mathematics. It's a pretty beautiful and elegant solution, don't you think? Using deep, natural order to protect our chaotic digital world.
It's a fascinating thought to leave you with. These patterns that have puzzled mathematicians for millennia might not just be a curiosity after all. They might just be the blueprint for a much more secure future. It seems the universe still has some incredible music left to share with us. Thanks for joining me.